Chapter 11, Constructions. Unit 11.1, Introduction. We already know the instruments which are there in a geometry box. Let us quickly revise the names and a few of their uses. 1. The ruler. We use this instrument to draw lines, segments, rays, etc. We also use the scale on the ruler to measure distances. 2. The divider. The divider has needles on both its arms. Both the arms are of the same length. The divider is used to attain precision while measuring lengths. 3. The compass. The compass has a needle on one arm and a pencil attachment on the other. For convenience in using a compass, always attach a small pencil on it and avoid removing it as far as possible. It is a very important tool which helps us to make precise geometrical constructions. The primary use of a compass is to draw circles and arcs of a given radius. Making use of the arcs, we can further draw bisectors, angles, triangles, quadrilaterals, etc. 4. The protractor. We use this semicircular scale to draw and measure angles. There are two scales marked on it, the inner scale and the outer scale. The range of both the scales is from 0 degrees to 180 degrees. We use the outer scale when the initial ray of the angle is pointing to the right, and the inner scale when the initial ray points to the left. 5. The pair of set squares. The two set squares are two right-angled triangles with scales marked on the sides that form the right angle. One of the triangles is a 45 degree, 90 degree triangle, and the other one is a 30 degree, 60 degree, 90 degree triangle. The set squares are mostly used for drawing perpendicular lines and segments, and also for drawing parallel lines. Unit 11.2, Basic Constructions.
Bisecting a given angle. Let's draw an angle X, Y, Z measuring 40 degrees and bisect it using the compass. Draw angle X, Y, Z measuring 40 degrees. Place the compass point on point Y. Taking a suitable span on the compass, draw an arc intersecting ray YX at point A and ray YZ at point B respectively. Keeping the same span on the compass, place the compass point on point A and draw an arc inside the angle. Similarly, place the compass point on point B and draw another arc intersecting the previous arc. Name the point of intersection as C. Draw ray YC. Thus, we have ray YC, which is the bisector of angle XYZ.
Let us now see how this method gives us the required angle bisector. Draw AC and BC. We get two triangles, triangle ACY and triangle BCY. Comparing the elements of both these triangles, we see YA and YB are the radii of the same arc and hence equal. Similarly, AC and BC are equal. YC is a common side. So, by the SSS rule, triangle ACY is congruent to triangle BCY. Hence, the corresponding angles of the two triangles will be congruent. This gives us angle AYC, which is equal to angle BYC, which implies that ray YC is the bisector of angle XYZ.
Let's practice. Draw an angle ABC measuring 90 degrees and bisect it using the compass. Draw angle ABC measuring 90 degrees. Place the compass point on point B. Taking a suitable span on the compass, draw an arc intersecting ray BA at point N and ray BC at point N respectively. Keeping the same span on the compass, place the compass point on point M and draw an arc inside the angle. Similarly, place the compass point on point N and draw another arc intersecting the previous arc. Name the point of intersection as O. Draw ray BO. Thus, we have ray BO, which is the bisector of angle ABC. Draw an angle MNO measuring 140 degrees and bisect it using the compass. Draw angle MNO measuring 140 degrees. Place the compass point on point N. Taking a suitable span on the compass, draw an arc intersecting ray NM at point X and ray NO at point Y respectively. Keeping the same span on the compass, place the compass point on point X and draw an arc inside the angle. Similarly, place the compass point on point Y and draw another arc intersecting the previous arc. Name the point of intersection as Z. Draw ray NZ. Thus, we have ray NZ, which is the bisector of angle MNO. The bisector and the perpendicular bisector. The bisector. Look at segment CD. It is 4 centimeters in length. The point E on this segment divides the segment into 2 equal parts. That is, segment CP is equal to segment DP is equal to 2 centimeters. Therefore, point P is called the midpoint of segment CD. In other words, point P bisects segment CD. Dividing a segment into two equal parts is termed as bisecting the segment. Let's draw three lines through the point P and name them I, M, N. All these lines are the bisectors of segment CD. The perpendicular bisector. Now, use a set square to find out which of the lines are perpendicular to line CD. You will see that only line I is perpendicular to segment CD. Therefore, line I is called the perpendicular bisector of segment CD. If a bisector of a line segment is perpendicular to the segment, it is called the perpendicular bisector of the segment. Remember that there can be infinite bisectors of a segment, but there can only be one perpendicular bisector. Drawing the perpendicular bisector of a line segment. Draw the perpendicular bisector of segment CD of length 6 cm. Draw segment CD of length 6 cm. Stretch the compass to a span that is more than half the length of segment CD, that is more than 3 cm. Place the compass point on point C and draw an arc on either side of segment CD. Keeping the same span, place the compass point on point D and draw an arc on either side of segment CD to intersect the previous arcs. Name the two intersection points as A and B. Draw line AB. Thus, we have line AB, which is the perpendicular bisector of segment CD.
Let us now see how this method gives us the perpendicular bisector of segment CD. Join AC, BC, AD and BD. Now, we have segments AC, BC, AD and BD. Consider triangles ACB and ADB. We see that sides CA and DA are the radii of the same arc and hence equal. Similarly, CB and DB are the radii of the same arc and so they are equal. AB is the common side. So, by the SSS rule of congruence, triangles ACB and ADB are congruent. Hence, the corresponding angles will be congruent. So, angle CAM is congruent to angle DAM. Now, consider triangles CAM and DAM. We already know that CA and DA are equal. Also, the angles CAM and DAM are equal. Since AM is the common side, we can say that triangles CAM and DAM are congruent by the SAS test. Therefore, the corresponding elements are equal. That is, CM is equal to DM and angle CMA is equal to angle DMA. Since CM is equal to DM, M is the midpoint of segment CD. Now, the sum of the angles CMA and DMA is 180 degrees. since they are the angles in a linear pair. So we conclude that angle CMA is equal to angle DMA, which is equal to 90 degrees. Thus, AB is perpendicular to CD and passes through M, which is the midpoint of CD. So we say that AB is the perpendicular bisector of CD.
Let's practice. Draw the perpendicular bisector of segment XY, which is 4 centimeters in length. Draw segment XY of length 4 centimeters. Stretch the compass to a span that is more than half the length of segment XY, that is more than 2 centimeters. Place the compass point on point X and draw an arc on either side of segment XY. Keeping the same span, place the compass point on point Y and draw an arc on either side of segment XY to intersect the previous arcs. Name the two intersection points as M and N. Draw line MN. Thus, we have line MN, which is the perpendicular bisector of segment XY.
Let us revise the construction of an angle without using a protractor. Consider ray BC as the initial ray. We have to construct a ray BA such that the measure of angle ABC will be equal to 60 degrees. Let us begin with drawing an arc. Take a suitable radius and draw an arc with center B. Let this arc intersect ray BC at point D. Now, taking the same radius, draw another arc with center D. Let this arc intersect the previous arc at A. Now, draw ray B. We now have angle ABC of measure 60 degrees. We will now see why we get an angle of exact 60 degrees by following this method. The method of drawing certain angles with a compass is based on some properties of a few special triangles. While drawing an angle of 60 degrees, we use the property of the equilateral triangle. We know that all the angles of an equilateral triangle measure 60 degrees and all the sides are equal. So, we have drawn all the three arcs of the same radius. Now, connect the points A and D by drawing a segment. We have BD is equal to DA, which is equal to AB. So, triangle ABD is an equilateral triangle and hence angles ABD, BAD and ADB are of measure 60 degrees. We will now construct an angle EBC of measure 30 degrees. Ray BC is the initial ray. Taking a suitable radius, draw an arc with point B as the center. Let the arc intersect the ray BC at D. Now, taking D as the center, draw an arc of the same radius which cuts the previous arc at A. Draw two arcs of the same radius by taking centers as A and D. Let these two arcs intersect at a point E. Produce ray BE. we now have our required angle ABC of measure 30 degrees. We keep the same radius for all the arcs that we draw in order to construct an angle. To draw an angle of 30 degrees, we follow the same steps for drawing an angle of 60 degrees. After the angle of 60 degrees is drawn, we bisect it to obtain two angles of 30 degrees each. Let us now see the construction of an angle measuring 120 degrees. Taking ray BC as the initial ray, let us construct an angle ABC of measure 120 degrees. For this, we will have to obtain the required ray B. The initial steps for construction will be the same as those for constructing an angle of 60 degrees. Taking a suitable radius, draw an arc with center B. The arc intersects ray BC at a point, say D. Taking the same radius, draw an arc with the center D. This arc intersects the previous arc at E. Now, draw our third arc with the same radius, taking E as the center. This arc intersects the first arc at point A. Produce ray BA. Hence, the obtained angle ABC is the required angle of measure 120 degrees. We keep the same radius for all the arcs that we draw in order to construct an angle. Again, for drawing an angle of 120 degrees, we draw an angle of 60 degrees first. Then, we draw another angle of 60 degrees using the 60 degree mark on the arc. We will now see the construction of an angle measuring 90 degrees. Take ray BC as the initial ray. We have to construct a ray B such that the measure of angle ABC formed will be 90 degrees. First, we will draw an arc of a suitable radius and length with B as the center. This arc intersects the ray BC at point D. Taking the same radius, draw arc with D as the center. This arc intersects the first arc at point E. Draw the third arc now, this time taking E as the center and keeping the radius the same. This arc cuts the first arc at point F. Draw two arcs of the same radius, one with F as the center and the second with E as the center. These two arcs intersect at the point A. Now, produce ray BA. We have angle ABC of measure 90 degrees. We keep the same radius for all the arcs that we draw in order to construct an angle. For drawing an angle of 90 degrees, we mark 60 degrees and 120 degrees on the long arc, and then, keeping the needle arm on these two marks, we draw two more arcs. The intersection point of these arcs, when joined to the point B, gives an angle of 90 degrees.